For most of automotive history, fuel choice was fixed. Gasoline cars ran on gas. Diesels ran on diesel. Everything was optimized for one supply chain, one assumption, one source. That assumption is breaking. Across military, industrial, and remote-use vehicles, engineers are reviving a different idea: multi-fuel capability. Vehicles designed to operate on more than one fuel type, diesel, kerosene, jet fuel, synthetic blends, are quietly returning. This isn't about novelty, it's about reliability. Fuel availability is never guaranteed. In disaster zones, remote regions, and contested environments, the question isn't efficiency, it's what's available right now. Multi-fuel vehicles trade peak optimization for operational certainty. The engineering challenge is non-trivial. Different fuels burn differently. They have different energy densities, ignition characteristics, lubrication needs, and contamination risks. Designing an engine to tolerate variation requires robust materials, conservative tuning, and mechanical resilience. That's the point. Multi-fuel engines prioritize survivability over perfection. Compression ratios are chosen for tolerance. Injection systems are designed to handle variability. Filtration is overbuilt. Controls are simplified to reduce dependency on precise inputs. In return, the vehicle keeps moving. This philosophy never disappeared. It just went out of fashion when supply chains felt stable. Now, as logistics grow more fragile and fuel diversity increases, the value proposition is back. Military adoption makes the logic obvious. A vehicle that can run on whatever fuel is available reduces logistical burden. Fewer supply types mean fewer failure points. In the field, flexibility equals mobility. But the same logic applies outside combat. Remote industries, humanitarian operations, and off-grid users face similar constraints. When fuel sources change, or when the right fuel isn't available, a vehicle that adapts keeps working. There's also a maintenance advantage. Multi-fuel designs are usually simpler. They rely less on extreme tuning and more on mechanical robustness. That makes them easier to diagnose and repair in harsh conditions. This doesn't mean multi-fuel vehicles are replacing single-fuel designs everywhere. Efficiency still matters where infrastructure is reliable, but the pendulum has swung far enough that resilience is once again a design goal. Flexibility is becoming a feature. As synthetic fuels, biofuels, and alternative blends enter the market, vehicles that can tolerate change gain long-term relevance. Instead of being locked to one energy assumption, they remain usable as conditions evolve. Multi-fuel capability isn't about the future of fuel. It's about the future of uncertainty. When conditions change, the vehicles that survive are the ones that don't care what's in the tank, only that something is. When fuel stops being predictable, the most valuable vehicle isn't the most efficient. It's the one that keeps moving.